going to do repeated reflections. That's one reflection after the other. We're going to learn about translation and composition. First thing we have to do is a little translation here. They gave us a bunch of coordinates, and we're going to try to do this. I'll do it right here. TUV has the coordinates, and I'll make a little rough sketch of a graph. T is at -1, -4. Let's pretend that that is there. U is at 6, 2. Let's pretend that's there. Oops, did that wrong. -1, -4. And B is at 5, -5. Now they're telling us how it's translated. 3 units up and 5 units left. That's like 2 moves, unless you do kind of a slanted move. But it's easiest to think of it as 2 moves. A move up and a move left. Matt.
Yes.
You're one of my sharper students. If I take T and move it 3 up and 5 left, what's that going to do to these 2 numbers here?
That's a put it at -3. No.
Okay, let's do let's
-6.
for the audience, for Hayden out there.
-6.
What will the 3 up do to this -4?
It will make it a -1 because
All right.
you have 3 possible.
What will the 5 left do?
That will make it a -11.
It's a -1 now.
Oh, no, that looks like 6.
I know, it's bad.
It'll be a -6.
So, -5, -1, you're saying? -6, -1, sorry. All right, let's try this again. A little smoother this time, Mitch. Mitch, the new T is going to be right there. U, if it goes 3 up and 5 left, what will happen to the point 6, 2?
It will be 1, 5.
It's got to go 5 left. 1, 5. Nice. He's good. Call that U prime. Will you help me, Nick, with V prime? It's presently at 5, -5. We got to go 3 up, 5 left.
I bring the good tissues.
Can you pan to show Becca coming in late?
Not late.
All right, now pan back to things that are important.
Thanks.
What's the wait for that? All right, Nick. What are you thinking, Nick?
0.
Well, it's at 6 now. It's got to
I
go
wanted to be
1.
We already did you.
very
Oh.
video.
I'm sorry.
So the 0, -2.
0, -2. Not bad. No. Now I'm going to connect the 3 originals. And the 3 new ones. And that triangle should look like it moved up and left. It would look even perfecter on graph paper, of course. Which of these choices is correct? Look those over. What do you think, Mackenzie?
We need to stop freaking moving this. I know.
D. All right, back up. Back up.
Yes.
I have a new one just for you here.
J.
I'll help you.
Okay.
We have this blue quadrilateral, same spot in every picture. Which one of these choices, answer choices, shows that it was moved 3 to the right, 4 down?
D.
She says D. We can check that. Bam! It's like she never missed anything. We want to move raindrop 2 to raindrop 3, and then raindrop 3 to raindrop 4. We want to go 2 moves. We have to find the translation that moves it really from spot 2 to spot 4. So they're saying then the first move is 2 left and 3 down. I think we can see that faster. Then they're saying the second move is just 3 down. Put them together. They're saying this first move is 2 to the left, 3 down. The second move is no left-right movement and 3 down. So that's how you would answer that kind. This question is talking about moving lightning bolts. I don't think anybody does that. But supposing we could move a lightning bolt, and we want to move it lightning bolt 3 to lightning bolt 4, and then lightning bolt 2 to lightning bolt 1. So we first want to do this, and then we want to do this. Can you see why the answer is B? That looks like the answer to this moving 3 to 4. Which one of these moves 2 to 1? about it.
2 to 1.
Lightning bolt 2 to lightning bolt 1. Were you thinking this one?
Yeah.
You're lying. You're just saying that. All right, this one should certainly trick Hayden because it's kind of hard. They want us to decide whether this is a translation image from here to here to here. Notice the little apostrophes. So they're saying this could go reflect to here and then this reflect to here, making this a double translation down here. You see anything wrong with that?
Yeah.
You think Hayden will fall for it though?
Yeah.
All right. So the correct answer is no, it's not. What about this one? Look at the apostrophes to decide which is the original. Could this be a reflection and then another reflection? Think about which answer you would pick there. Which answer you think Hayden would pick. Yep, we got it right. Okay, we're doing another lesson. Tell Becca to be quiet.
I didn't say anything.
Oh, she was just about ready to start whining again. Draw rotated images we're going to do now. Looking for rotational symmetry too. We're going to rotate a quad. Where's my... here it is. Yeah, just... Becca's just messing around back there. All right, Becca, are you ready?
Sure.
We're going to rotate this quadrilateral 45 degrees counterclockwise around point A.
Just had this in the way.
Mitch, you're bothering her. I drew a line from A to one of the points, and we want to go 45 degrees counterclockwise. That's like this way around, you know, because the clock goes the other way. 45 would be up in this direction.
No,
Shh. So the new R has to be just this far out on that line.
Did they give you the point A? Joe, move your head. Yes, they do.
So we'll make a little mark like that. The new A will go right there. I mean the new R, I should say the new R, R prime.
Did you find the answer?
I have to do that 3 more times. Now I have to do it for S.
Seems like a lot of work.
Could you get a little recording there, Megan, of the kids that are being bad out there?
Mitchell! Move your butt!
I'd like to know.
I see how educated this video is going to be.
I need to know which parents to mail this video to.
I think Mitchell's dad would burst out loud. It's just kind of guy.
that dotted line should be 45 degrees away from the line to S. So now quickly measure the distance out to S, so that stays the same. I'll make a little mark right there. S prime belongs out here. Got to do it to T now.
I can't, because both in the way.
Right on the desk.
Oh my hands up good.
Check the distance to the old T, put the new T that far out.
So do you just try and split the degree and say 5?
Everyone's moved clockwise, 45 degrees, counterclockwise. One left to do. If you manage to miss the first 3 times, like, you get one more chance here. I need to move V 45 degrees. So draw a line from A out through V. Measure 45-degree angle. Mark off that distance. That's V prime. Connect them all. V to R. S. T. Now it should look like the original was rotated or spun around A 45 degrees.
That looks like a lot of work. Do we have to do a lot of those?
For the record, that's my whiner, official whiner, Becca Hofer.
Just starting a poster.
Looks like a lot of work.
Alright.
Poster.
I wasn't whining, I was asking.
So he's the teacher, and Price the teacher, whined at the
Wow.
teacher.
I didn't wind at the teacher. So we do it there. What's on there?
We need a new poster.
Posted this on the wall.
All the seconds. That's a good point where
There's
there's
another sample of that. I don't think I need to do 3 of those. Alright, take a look at this one. Which one of these 4 choices appears to have been rotated 70 degrees around -1,1?
How do we know if it's 70 degrees?
There's the original, there's -1,1. Which one of these looks like it rotated 70 degrees counterclockwise? Looks like the original is the green one. No, not in all of them. You have to look at the apostrophes. Do you have a guess, Nathan?
D.
D? You're thinking D?
Yeah.
Let's see if he's right. Whoa, he's good. He's good. Apparently, right here, this blue triangle has swiveled about 70 degrees counterclockwise around this point. That boy has a good eye, pays attention. I don't think I heard any whining from him yet today either.
Not cool.
Said, she's whining.
Back up. In whatever whiny voice you wish, could you please read this?
In a given rotation, if A is the pre-image, A is the image, and P is the center of rotation, then the measure of the angle of rotation, AP, primary A, is that it?
Double prime A.
Prime A is twice the measure of the acute or right angle formed by the intersection lines of reflection.
And actually corollary 9.1 just says it more simply. Reflecting an image twice is a 180-degree rotation. All right, we're going to do one of those. We're going to do this one a little faster. I'm going to reflect it across P and then across Q. I'm looking at point Z. And I'm thinking if you go across P, point Z would land about here. And then if you go across line Q, it would land about here. So I'm going to put Z double prime right there and erase that. I'm going to try it with W. W is presently there, so I have to come straight across.
Not important enough.
1, 2, 3, 4, 5, 6, 7 and a half. Half. 1 half, 1 half, 2 half, 3 half, 4 half, 5 half, 6 half, 7. So it comes to about there. When it goes across Q, stays about the same place. So W prime will be about there. W double prime. We're going to do Y now.
I felt compassion this way.
That'll come across to about here. That'll be Y first prime. No, wait, it's got to go across P first. So we'll go first to here, and then out to here. So Y double prime should end up there. And finally X. Goes first across P.
Why is it called double prime?
Because if I reflected across P, single prime would actually be there.
Okay.
I need to get the right on the corner.
Connect them
I
together.
don't want to do
So is there also such thing as like Y triple prime?
It could go on and on, but the point I want to make is that if you do a double reflection, first across one line and then across another line, it'll end up looking like it rotated around this spot. So if you look at that, you should be able to see that it looks like it went and just rotated. And the rule that Becca read said that the degrees it rotated will be twice as much as this degrees there. Becca?
If you bisected that angle, couldn't you make the same thing happen in one?
Yeah, that's the point. So you could do two reflections or one rotation and achieve the same thing. Now, Nathan was pretty good on that last one. Which triangle is the image of ABC double reflected across M and then N?
Green.
Is it the green one? That would be B. You guys are good. It is B, the green one. We have a nice quilt here, made by Judy Matheson.
Good job, Judy.
Wow.
We'd like to identify the order of magnitude of the symmetry in the medium star directly to the left of the large star in the center of the quilt. I believe they're talking about this star. They want you to describe the symmetry, the order and magnitude of the symmetry. How many times could you take this star and rotate it and have it look just like it did before? Nick? You see this star? It's kind of symmetric. If you rotate it a little bit, it'll look like it did before. How many times could you rotate it and have it look like it did before you're all the way back to where you started? That's probably 16. Because that could go to there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It has 16 points.
But can't you also go on the index so then it would be 32?
Well, they're not asking about lines of symmetry. I think they're asking about how many times you can rotate it. So
I guess I
Nick
could do
is
that too.
right. You could rotate it 16 times
Everyone was
before you're
fine.
back to where you started. And then each rotation would be, where does this number come from? How could you get this number?
That's how many times it takes to get to 360. So you go by that increment.
So you're saying 360 divided by 16 would be that?
Yeah.
Yeah, good call by the Mitch. Ooh, let's do one more. Let's see if Matea is sharp today. Because we don't have Hayden for our usual great sharpness. Everybody's laughing. We're going to talk about the magnitude of symmetry in the tiny star above the medium-sized star. I think they mean that one. Can you even see that, Matea? It's a good thing I picked somebody in the front. How many times could you rotate that?
8.
So 8 would be the order of the symmetry. The magnitude would be how big are the rotations?
Wow. 360 divided by 8.
360 divided by 8.
I don't know what it is.
Could that be 45?
Yeah.
All right, she's thinking yeah. Upper left corner. I believe they are now speaking of that one. Morgan, are you Hayden's Facebook friend?
Yeah.
Oh. Just wondering. How many times could you rotate that one? Thinking 8?
Yeah. It'd be.
So you're thinking B? Very nice.
What's the
Okay, you mean.
More.
We're done?
What does it mean when it says the magnitude?
how big the rotations would be and how many degrees to get to the next
How
spot.
many degrees from one currency to
Yeah.
the next one will shift?
Yeah, that's,